There you go. And you are all muted as an attendee. If you have a question, you can post your question in the Q&A box, or you can unmute yourself and ask the question. So either way will work fine, and we will try to answer as we go. We have some Q&A session in the end too. So let's get it started. So today's high-level agenda, introduction, and then just an overview of current state, what's going on in healthcare and ransomware and cyber attacks. Most of you know about it, but just I thought it would be good to recap the current state, current situation. And then Matt will go over and introduce you about virtual cloud network, NSX network insight, like a brief overview, and then we go into deeper discussion around like using microsegmentation and automation, guest introspection, service insertion using third party, and app defense whitelisting. How we can use all these features and capabilities to protect from ransomware and security threats. We will also go over some of the network and security VMworld announcements. So Matt will go along as he presents. He will mention some of those announcements. And then we have Q&A in the end, but we will also have a Q&A during the presentation if you have any questions. All right. So just to kind of go over real quick, what is VMware doing with healthcare IT in their digital transformation? So VMware is helping our customers in transforming their healthcare IT and in their journey to digital transformation. VMware believes that modernizing data center, integration with public cloud for hybrid cloud model, and delivering digital workspace and transforming security are the key IT forces that are impacting healthcare right now. And the business outcomes from these IT forces are to reduce cost and complexity, mobilize your providers and engage more patients, and secure patient information. I mean, that's kind of the key topic today that we will discuss. And then we call these four key IT forces as the pillars of digital transformation. Today we will be focusing around digital transformation. Transforming your security, and that's what will be covered most of the time, and in most of the slides today. Later on, when we have other sessions, other webinars, we will cover other pillars of our digital transformation. So just to everyone knows what's going on around cyber attacks and ransomware. Just to recap, right? Cyber attacks in healthcare organizations are the #1 cause of data breaches now, and they were in 2017. And 90% of healthcare organizations in a study experienced a data breach in the past 2 years. Ransomware, malware, and denial of services are the top cyber threats that are facing healthcare organizations. And healthcare industry expect to have more and more of these cyber attacks in the form of ransomware, malware, and DDoS. And it's predicted in 2018 and future, healthcare industry is #1 target because the information they steal is so valuable to the hackers and bad guys. So if you just do a Google search and try to see, I just did it a few days ago, and you will see all kinds of new headlines about data breaches in healthcare industry. So it's like happening today, yesterday. I mean, happened yesterday, it will happen tomorrow. So it's like a really common theme that we hear in the news articles everywhere. So what is ransomware? I mean, that's pretty common term that people and you may already know. I'm just repeating here what you may already know. It's basically a type of malware that takes control of a computer or a computer system by encrypting all the data on the drive. So basically, when you try to access your files, you see this big red screen that's shown on the right-hand side that you're unable to access your files, and the guys, hackers are asking for ransom, basically, to allow you to access those files, and those ransom is usually asked in Bitcoins because it's hard to track. So that's kind of what ransomware is. And I just thought to recap that. And traditionally, what are the methods to prevent these? People use backup. They use some antivirus or anti-malware software, or perimeter firewalls, or some customers use internal firewalls. So, and these all methods are not exclusive. They use in combination. So in a backup, you create a backup and then keep the backup in an isolated environment. So if something happens, then you try to recover the data. The side effects of that are the data can get corrupted, or it takes a long time to recover the data to come back online. So if you have mission critical applications, you can't have an hour, 2 hour downtime. And anti-malware software, they are to some extent are effective, but the signature updates, in my opinion, is not fast enough. Hackers are faster than anti-malware, anti-virus software companies. I don't know. Maybe hackers are smarter. And the perimeter firewall, that's a traditional approach to protect the inside network from internet. Typically, there's a firewall, and there are some internal firewalls to provide a macro segmentation. And those are, we see them a lot. But having all three methods, ransomware attacks and cyber attacks are still happening, right? So there has to be a different approach, a different way, and more effective way to prevent cyber attacks. So then I will hand it over to my counterpart, Matt Just, and he will go over some of the details, more technical details. So Matt, I will stop sharing and I will let you take control.
Okay, thank you, Adam. Are you able to see my screen okay?
Yeah, I see the slides and sub-slides on the side. I don't know if that's the format you have. Or do you want to show on a full screen?
Let me make a switch to that.
Okay.
Okay, so now you should be able to see.
Yep. That's okay. Thank you.
Okay, and thanks for the introduction, Adam. As Adam mentioned, my name is Matt Just. I'm with the Network and Security Business Unit at VMware, focused on in the healthcare industry on all products network and security related within our portfolio that we'll actually be talking about and discussing in today's webinar. To start off, what I'd like to do is kind of talk a little bit about the vision that, from as far as where VMware is going and where we are today. You'll hear a lot of different terms that are thrown out there and that we've kind of been adopting as we've brought on new products and new capabilities in our portfolio. So our approach is basically, we've looked at the network for the past 20 years. And when we're looking at the actual, the way that we've been doing networking and security over the past 20 years is that, we focus on physical elements. We've been focusing on the physical network, physical security, so firewalls, routers, switches, and so on, to be able to provide those functions and level of protection from a security posture standpoint for our data centers and our applications. We are looking, our shift is to look now into the future for the next 20 years, and software-defined data center, software-defined networking, software-defined security, you hear many different terms out there, is really driving the change as to being able to provide security and networking at the speed of business utilizing software rather than hardware as we did in the past. So as we move forward, you'll start to see some of the discussions that we'll talk about with some of the products, and we've basically been able to expand our portfolio, as you can see, from going from just the data center now all the way out to the branch, out to the cloud, and you'll hear, we basically, our portfolio supports any device, any cloud, any application. Move on to the next slide here. So, virtual cloud networking, connecting and protecting workloads across any environment is what we offer and where we are today. You'll hear a lot of talk about NSX, and NSX is our platform that we have built upon to be able to provide this level of protection across these environments, whether it's private data centers, public clouds, Internet of Things, branch offices, users, things, as far as any app, any type of data, and so on. So the big thing that, we face today is, changing the application security model. How do we go from chasing the bad to ensuring the good? When we look at, data that we store, whether it's in a data center all the way out to a branch or in the cloud, when we look at security controls, we're implementing controls that typically are chasing the bad. We learn about, different attacks, and we update software, we update agents and so on that's running inside the software is what we see, traditionally. And it's become very difficult in chasing any type of malware or ransomware because attacks are asymmetrical. So, an attacker tends to have the advantage. They throw 1,000 arrows at us and, they hope one sticks. And then once they're in there, they're able to set up their C2 points, their command and control points, and start moving laterally within our environments, within our data center. So our goal is to, stop necessarily chasing the bad and start to ensure the good. So that way we can eliminate the possibility of zero-day exploits, ransomware, and so on. So, in the healthcare industry, one of the big things that I deal with a lot of different customers is electronic health records. Everybody from, when we're dealing with, various hospitals and so on, are dealing with EMR, EHR, health records, and so on. And what we see today is, the more digital we become, the more we're seeing patient data and so on building and building and building, and it is, it gets to a point where we need to protect this data because of strict requirements that are placed by different organizations such as HIPAA, PCI, PHI, and so on. So, when we look at the problem with the electronic health records is that, the incentive to breach, when we look at some of the statistics, we're looking at the average cost per stolen identity record in 2016 was $158, but the medical record is worth $355. So, the concept of more spending and throwing more spending at security protection, whether it be hardware-based or even, antivirus or some type of malware protection, it becomes, very difficult to keep up at the speed of, business when it comes to the way that attackers are attacking our industry today. So we need to change how we're actually applying security, and that's what we'll be talking about. Another point, that we run into also is within hospitals and clinics is the ability to secure our clinical endpoints. So, this whole BYOD, or bring your own device, philosophy has grown so much that it's become a very difficult challenge as we onboard all these devices within our infrastructure. We're basically expanding our attack surface. So we're allowing for larger attack surfaces by adding, all these additional devices. within our infrastructure, and it becomes a challenge because we need to be able to have these devices. We have patients that want to be able to use devices. We have doctors that want to use devices, and so on. And they're bringing their iPads and different mobile devices in and attaching them to the network, and that becomes a very strong area for control when it comes to providing access to that data and ensuring that that data isn't subject to malware or ransomware or stolen from the data center. So when we talk about VMware network and security, NSX is basically, it's the best way to explain it is our platform. We started off with NSX, you'll hear a lot of terms around microsegmentation and networking. NSX is our network and security overlay platform that we have built upon here at VMware to expand and provide networking and security, not just in the data center, but taking that and extending it all the way out to the end user. So going from the data center to the branches, to clinics, to the end users, whether it's doctors, patients, and so on. And we've grown that with different products. So you'll hear different things in regards to NSX SD-WAN by VeloCloud, providing secure connectivity services. So that's our SD-WAN service that allows us to provide secure connectivity from the data center out to all of the clinics and the different branches or various hospitals. NSX Data Center, exactly as I was talking, providing those virtual networking functions, microsegmentation utilizing a distributed firewall across all applications in the data center, virtual network functions such as routing, switching, load balancing, NSX Cloud, which is basically providing our cloud native network services. So when we're dealing with whether it's AWS or VMware Cloud on AWS or Azure or Google or any other VMware Cloud provider, we're able to extend those security functions and networking functions that NSX provides today in the traditional on-premises data center and extend those same functionalities out to these public clouds with the same touch, feel, single pane of glass management from a security perspective and from a networking perspective. And then also what we'll touch on too today is a little bit on app defense and also on network insights, or you'll hear it referenced as vRealize network insights. We have which is our visibility tool that we utilize, and also a day two operational tool to utilize to help manage these environments as you implement them within the data center. So today's problem that we typically run into, we have our data center, starting off at our data center level, we're trying to protect the data center. So traditionally, and we put, large, very expensive perimeter-based firewalls, could be any vendor, to try to protect our data center. And this is going out to the internet. It could be VDI users connecting in. It could be, you name it, coming into our data center, and we throw these large firewalls, and we hope that they can protect and isolate all of our applications running in our data centers today. The problem is that when an attacker gets through these perimeter firewalls, they can easily get access to applications running in the data center. They'll search for specific applications, we can say like a web application, and set up shop, and then they'll start creating what we call C2 points, or command and control. So they'll start moving east-west inside the data center and start setting up shop, and then start mining the data out of the data center to a point where the perimeter firewall doesn't catch that they're actually doing this. And that's how we run into these data breaches that we see daily happening to all these large corporations. So, we tend to try to start deploying, more physical firewalls in our data centers. And the problem with it is with all of the costs associated with trying to implement all of these other firewalls inside the actual data center beyond the perimeter becomes very costly, and it's very hard to manage from a firewall rule perspective, We deal with, hardware that, hits its limitation on average from a 5 to 7 year basis where the hardware needs to be replaced. And then we're also dealing with, we live in a virtual world. 80 to 90% of all data centers are virtualized today. And we even have customers that are running at 100% virtualization. And the problem is that, when all of the data is living in a virtual environment, you have to send that data out to these firewalls and then back into the virtual environment. So now we start getting into hairpinning data as we're providing security controls to protect the data, because in most cases in the data center, when you actually analyze your traffic in your data center, 80 to 90% of our traffic is actually east-west traffic, believe it or not. So when we look at the traffic, we're seeing lateral movement east-west, application to application communication, whether it's in the same physical server or host, or if it's in 2 different data centers, a data center to the cloud, or it could be within the same data center. So it becomes a challenge. So, and this just touches on what we were, just talking about. So our current firewall architecture today, we have our outside attacker that, basically is doing everything they can to penetrate that perimeter firewall, which we showed demonstrated there. And then what also happens is, once they gain access, obviously they can start extracting data, but we also run into issues that we've got to watch for, with attackers when they are, sending malicious emails. So you may get an email that looks like it was sent to you by somebody you work with, and it has an attachment. It could be a PDF file, for instance, and you open up that PDF file thinking it's something that was intended and that you're interested in, and that doesn't have any type of malicious code. But what happens is that actually in most cases opens up a reverse TCP connection out to the attacker, and then gives the attacker control of specific devices within the data center. So when we move into talking about NSX, so providing that security, as we talked about, deploying physical firewalls within the data center becoming very costly and hard to manage. What NSX allows us to do is it allows us to take the existing VMware environment you have today, so your existing vSphere environment that you're currently running in your data center today, and add what we call a single VIB or a VMware installation bundle. So we push out a VIB to each one of the physical hosts running these hypervisors, and this VIB enables the NSX capabilities within your infrastructure, such as being able to do distributed firewalling. Distributed firewalling allows us to basically provide a firewall in the hypervisor for every single virtual machine running inside your infrastructure. So at each VM level, we are providing firewalling rather than trying to do it all using physical firewalls within the data center. We're implementing this as closest to the application as possible. The goal is, and the nice part about this is that with NSX, because we're actually implementing this level of security and other networking functions in the hypervisor, we do not require the use of any types of agents. So we're not implementing any types of agents within any of the virtual machines. And we also do not require any type of physical networking components to be deployed. So we're not actually going out in the network. We're not actually putting anything in any of the virtual machines affecting the network, the CPU and the memory utilizations of these machines. We are doing it all inside the hypervisor, which kind of puts us in, as we refer to, as a Goldilocks zone. We're not, like I said, not impacting the application, not impacting the network. We're putting these controls in the hypervisor, which if you do any type of research on attacks within a hypervisor, you'll notice that you won't find them out there, because the hypervisor puts us in that special place that when an attacker attacks, they're either going to attack from the physical network, or they're going to get into an application running in the environment and then start spreading east-west from application to application. So as we mentioned, we talked about distributed firewall being available via NSX for every single application, virtual machine running inside your environment. So with NSX being positioned, today we have our physical network, we have our physical compute, we add the hypervisor in, which the hypervisors. Well, we just celebrated our 20th anniversary, so for 20 years now. VMware's been one of the leaders in the market when it comes to providing hypervisor and virtual capabilities. So with NSX, we position NSX, as I mentioned, in the hypervisor, which gives us that level of visibility we need to be able to see into all of the applications running in our data center. And with that, we are able to provide firewall and automation everywhere. So we go from what we looked at, providing all of these physical firewalls inside our data center and our perimeter firewall, which you always will have your perimeter firewall, obviously protecting from outcoming sources. And but when you deploy NSX, you're now implementing these security controls and these networking controls inside each hypervisor distributed across your data centers, including the cloud. So, as we mentioned, leveraging the software-defined data center approach for microsegmentation. So again, hypervisor-based in-kernel distributed firewalling. Now this is line rate firewalling. So x86 architecture allows us to provide firewalling inside the kernel at line rate, which is essentially going to be 20 gigs of throughput of layers 2 through 7 stateful inspection on a per VM basis. And from a performance factor, when you look at the old traditional model of utilizing either physical firewall or utilizing even a virtual VM-based firewall, there's been a lot of challenges because of the restrictions on the throughput capabilities of the virtual firewall VM-based. So it limits us to the number of actual virtual machines that we can run on each physical host, and that can become costly. So traditionally, most customers will end up implementing the physical firewall approach because they can handle more throughput. Well, with NSX, because we are handling the layer 2 through 7 inspection through our distributed firewall, we're now offloading all of that. And so we remove those requirements and those restraints of having to actually run those additional physical firewalls and hairpinning our traffic out to those firewalls, even if it's a virtual machine that's trying to communicate with another virtual machine running on the same physical host. So when we look at this, basically today, the virtual machine goes out through the physical network, hits our perimeter firewall, and goes out to the internet. Now, when we take NSX and we push those VIBs to each host, we've now prepped the host with the distributed firewall, and we're now providing that protection to each individual virtual machine. The benefit of this is that because we're providing this stateful security posture to each virtual machine, any traffic going from that virtual machine is being inspected as it passed through the hypervisor, whether it's incoming and outgoing. The other benefit is every time we want to move our virtual machine, having that flexibility and being able to adapt, whether we want to migrate a virtual machine from one host to the other, or from one host to, let's say, AWS, or maybe we purchased and we're doing mergers and acquisitions. We have the ability to utilize the software-defined network overlay that NSX provides to be able to provide these security postures and extend them out to other entities. So that way, when we vMotion or migrate workloads from one site to another, from one host to another, this security posture maintains state the entire time that application is being moved. So as we can see here, we're communicating, we're hitting our distributed firewall. I can vMotion this over to another host. While I vMotion it, it is fully protected as it moves from one host to the other and maintains that security posture. When we typically deal with some scenarios, for instance, maybe a disaster recovery scenario from one data center to the other, we run into some challenges of, in a non-NSX environment, we are actually taking and we are failing applications over from one data center to the other, or it could be from one data center to the cloud. An issue that we run into is when we do that, the amount of time it takes to bring those applications back up. And that is because when the application moves from one data center to the other, it typically is changing IP address, and it also typically requires some type of change in the routing infrastructure on the physical network so that the application is known how to be reached, and also requires some type of configuration on the physical firewalls in the DR data center to be able to support that application. The benefit with NSX is as that application moves from one data center to the other, one data center to the cloud, the IP address of that application never changes, and the security posture never changes. It is extended across all data centers. So those elements that we have to engage as far as getting firewall rules deployed as we move applications and getting new IP addresses and changing the routing now are all eliminated with the capabilities of NSX being able to support basically any cloud, any device, any application. So moving forward with talking about microsegmentation. Microsegmentation is the term we utilize when we're talking about providing that level of security on a per application basis. Now, microsegmentation can also extend to whether we're dealing with isolation. So if we have application developers creating applications, they may be connecting in from overseas using a VPN. Well, we typically have to build out, some type of a dev environment for these developers to develop applications, and that becomes time-consuming on managing that, and then also being able to really understand that application and learn about that application, so that way when we move it to production, we know what type of security posture we need to implement for that application based on its function. So with NSX utilizing microsegmentation, we can actually provide that isolation between different departments such as dev, test, and production, and build that out with automation and ensure that we are providing that level of security and the level of visibility required, so that when we move that application into production, we ensure that it receives the correct security posture in an automated fashion. We also provide the segmentation between web app, DB, and we can then also include service insertion. So we have a large eco partner, which I'll actually show the list of eco partners that we have that work with our products today. So if we have a security team that is utilizing, let's say today, Palo Alto or Checkpoint or even Cisco ASA firewalls, for instance, or various different other firewall vendors, and they like the look at they like the software that they're using, because the management software for those firewalls to manage their physical firewalls, and maybe if they're running some of the virtual VM-based firewalls, and they don't want to have to go to two different points to manage security. The great thing about NSX is because of our open eco partner system, we allow all of our third-party vendors to be able to integrate into NSX directly using our APIs, such as our RESTful APIs and our NetX APIs. So this allows us to provide that same single pane of glass management point that our security teams are used to utilizing today, whether it's implementing security using different SIMs and so on to monitor events. We can provide all of those direct connects into NSX so that you don't have to learn or manage from two different points from a security perspective. Now, another key component of when you're utilizing NSX is because NSX is running in the hypervisor, we're tied into vCenter. So we have the ability to connect to vCenter and see everything from how are you configuring and managing your virtual machines today? Are you doing it by folders? Are you doing it by operating system? Are you doing it by the type of application tier or by regulation requirements? Are you using security tags on VMs and so on? Everybody manages their VMs within vCenter in different fashions. But with NSX, what we have the ability to do is kind of decouple the network from and the security from the application, and utilize vCenter constructs. So when we create our firewall rules in the distributed firewall and we apply those across all of our hosts, we are able to do it without having to use IP addresses. So we're not actually going out and creating those traditional access control lists like we would in a traditional firewall. We use things like operating system, the machine name, services, application tier, regulatory requirements, let's say PCI, and we'd start tagging VMs with PCI. I can write a single rule for PCI and basically say, apply this rule to all VMs that have a tag to them that says PCI. And when I apply that rule, it could be 500 VMs that have those tags. All 500 VMs are now secured with that rule without having to write individual firewall rules utilizing the IP address of every single virtual machine. So that's the intent of the distributed firewall, is to be able to utilize the components and that, various constructs that we traditionally use as we build out applications within our environments today via vCenter. Okay, so with that, we talked about electronic health records. So when we get into, implementing microsegmentation, this is where we can get into putting in those distributed firewall rules and actually across every single VM. So we have our distributed firewalls deployed within NSX on all of your existing vSphere hosts. And we're now providing security and posture to every single virtual machine. So when it comes to the healthcare industry and dealing with electronic health records, if an attacker tries to get in and now, infect a virtual machine and try to move east-west and set up shop and basically start to steal data, because we are implementing security controls in the hypervisor at the VM level, we now have isolated the ability for an attacker to be able to move laterally within our data center. So because we're providing that security controls as closest to the application as possible. Now, the nice, with integration with things like VRA and or vRealize automation and vCenter and so on, we're also able to provide adaptable and proactive security. We can define constructs and measures to be able to, integrate with various components such as NSX and App Defense to be able to provide that security in an automated fashion and at the speed of business. So when we talk about, we have unique policy definitions, we're dealing with vulnerability scans, CVE scores, and so on, and remediate changes with preset policy definition. So again, if tagged, remediate with IPS or intrusion prevention. So one of the things that we talked, I touched on briefly is we have the eco-partner integration, so service insertion. We have the ability to service chain, and I'm just using Palo Alto Networks as an example. So if our security team is utilizing Panorama and utilizing, let's say Palo Alto VM series firewalls and Palo Alto physical firewalls within the environment, due to the direct integration that we have with Palo Alto and other eco partners, we are able to connect, for instance, that same single pane of glass in this environment, which is Panorama, which is the software that the security admins would be using to manage the firewalls today. If they were using Palo Alto firewalls, would integrate directly with the NSX manager. This allows also so that anytime a new host is spun up or an existing host is in place, to deploy and push the Palo Alto VM series firewalls, if chosen to be used, out to each physical host. Now these Palo Alto and other eco-partner-based firewalls now become an extension of NSX. They're not seen as actually a separate firewall or separate gateway that we have to send traffic to. They are viewed as an additional attachment, next-gen firewall to provide, let's say, a service like IPS, intrusion prevention. So what NSX will do is NSX will actually handle all of the layer 2 through 7 inspection utilizing the distributed firewall and offload the throughput, from a throughput perspective, how much traffic we actually punt over to the third-party firewall before it actually goes out to its destination. So here's a security policy. Security admin applies that policy both to the physical firewall on the perimeter and also out to the each host. So now NSX and the EcoPartner-based firewall vendor are fully aware of each other, and what they're doing is from a security posture perspective, and they are working in conjunctions with each other. So as I send traffic, like again, the NSX distributed firewall is handling layer 2 through 7 inspection, and then any type of other next-gen based firewall inspection we want to add, whether it's IPS or IDS and so on, is punted over through the in the kernel, not as a not pointing it to as a separate gateway, through the kernel to be able to provide that extra service provided by the third-party EcoPartner integration via the NetX API and the RESTful API that we provide. Another key component when we're dealing with data center, whether it's dealing with applications running in our data center or even VDI, virtual desktops, doesn't matter if it's VMware Horizon or if it's Citrix, NSX has full capabilities to work with either or. So when we deal with antivirus, we're start to deal with in a lot of cases we're deploying today traditionally agents in every single one of our virtual machines, and these agents can have an impact on the performance of the virtual machine, whether it's memory or CPU utilization, and then also when Patch Tuesday comes around and patches are being pushed out to all of these different antivirus software that's running in our virtual machines or in our virtual desktops. It can be a strong resource hit across the board when this is being done, because NSX integrates with these partners such as Trend Micro and McAfee and Symantec and so on. We are able to provide antivirus scans without having to utilize agents. So it's an agentless antivirus scanning system that NSX can help provide, and to remediate any type of antivirus scanning, and to also integrate with NSX if a virus is found. So here's a standard policy definition. Standard web server VM policy. We have an antivirus we want to scan. We're going to allow HTTPS inbound traffic. We're going to allow common services outbound, and we're going to block all web-to-web traffic. If we find a virus, we are going to implement a quarantine VM policy. This would be at the firewall. We're going to block all except security tools, and antivirus we're going to scan and remediate. So this is a predefined policy definition that we would deploy and implement within NSX. And then what would happen is, as we build out if we look at the network here, we see our virtual network, we see our NSX components and our applications running, and we have our security group configured, and we're looking at our web tier here. Now we're scanning antivirus agentlessly across all of our applications, and we just found that 2 of our virtual machines have viruses. The virus, whether the EcoPartner from a virus perspective, whether it's Trend, McAfee, again, the list goes on and on and on, will tag that virtual machine, and as we see up in the upper right-hand corner here, a tag was applied that said antivirus found, layer 2 isolated network. So NSX will actually see that tag and act dynamically and actually move and implement that quarantine VM policy, and it's going to block all except security tools, and it's going to scan and remediate utilizing in conjunction with the third partner integration from an antivirus perspective. So we scan, we remediate, and then the tag gets removed by the antivirus software, and NSX sees that that tag is removed and will dynamically move the application back into production and restore it back to its standard web server VM policy. Now, this is basically what we're out to achieve, and when we're dealing with security. And this is actually a report from an actual customer that is running NSX today. So you can see the before and afters. Starting off, we had, within our Windows tier, they had 34 virtual machines. During a scan, a vulnerability scan, it was found that they had over 2 million ports open. Their reporting tier had 8 VMs, database tier 6 VMs, and then their presentation tier within VDI had 128 Citrix VMs and 57 View servers. You can see the list of ports before and then after NSX was implemented in isolating these virtual machines and only allowing the ports that needed to be opened from so that application can function. You can see how drastically the attack surface is reduced. And it looks like my slide is a little overlapping, but basically what this is showing is we also now and have been supporting container networking. So all of the major providers out there and frameworks and platforms as a service, whether it's Kubernetes, OpenShift, Pivotal Container Service, Pivotal Cloud Foundry, and so on, NSX now has a capability of taking that same level of microsegmentation that we're implementing at the VM level and extending that to the container level and providing those same security controls. So moving on from NSX to App Defense. Now, App Defense is, when we talk about data security, we talked about network security, compute security is already provided today in vSphere. There's different components that we can utilize within vSphere to provide some compute security. Now we're talking about data security. So we're getting into looking in at the actual processes running inside each application and trying to understand those processes. So App Defense is a product that it was released actually last year during VMworld and has been evolving very rapidly. And during VMworld 2018 here in the US, we announced some new features, which I'll cover here, that we've added to App Defense. So if you're not familiar with App Defense, what App Defense does is basically we are enforcing the known good. So when we take a look at our VMs and our applications running in our data center, we are now looking, utilizing the hypervisor, similar as we do with NSX. We have the ability to see into Windows machines, which was our initial release, and now we support all the major distros of Linux. So we can actually look into Windows-based machines and Linux-based machines and start to look at all of the processes running in those applications. And what we're going to do is App Defense is going to take a snapshot of the known state of the original deployment and any authorized changes, and it's going to basically create a birth certificate or a manifest saying this is the intended state, this is the known good that this application is functioning. Now, if something was to change, whether it is a service, it could be, for instance, if we talk about some of the recent vulnerabilities and ransomwares, they go in and they attack, for instance, like a small SMB port. So if App Defense detects any type of change from the known good manifest that we actually capture, we have the ability to provide alerting to the security team and to the application team to determine if that behavior is intended and is part of the application, or if that is malicious. And then upon finding out that that is actually malicious, then we have the ability to take action and raise, not only alerts, but do things such as isolate the virtual machine, whether we suspend it, power it off. If we have NSX deployed in the environment, App Defense does not require NSX. But if we do have NSX in our deployment as part of our new microsegmentation 2.0 model, we can do adaptive microsegmentation where App Defense can communicate with NSX and tell NSX, hey, isolate these network ports to this application based on this malicious activity that I'm seeing or unintended change in the application based on the actual service and the ports that service is that service is utilizing. So protecting critical applications. So App Defense again embeds threat detection and response into the hypervisor. So it's authoritative knowledge of the application intended state. We study what's good. We also study what's good from all of our customers and different changes that may occur and so on, and we have the ability of pushing down those updates to our app defense customers. So as we learn about other vulnerabilities and so on, or other weird actions taking place within specific types of applications, we have the ability to update each customer through our portal connection to App Defense and provide that real-time protection. So basically eliminating the possibility from a zero-day threat. We automate that threat response, and then we can isolate from the attack surface. And again, when we talk about what we're looking at, when we say known good, we're looking at machine contacts, we're looking at control and security policies, network topology, application flows down to the processing level. We're looking at code signing and authorization. We're looking at process and network behavior, runtime behaviors, developer workflows, infrastructure events. We're looking at all of this, as we call the DNA of the application, and studying that and manifesting it. So step 2 basically is we're running our we're looking at the intentional state, and we're connecting into the guest, and we're looking at, again, the various components, monitoring, and the operating system, and we're manifesting that. And then step 3 would be to react with our remediation capabilities. So this could be various components. This can be integration with NSX. It could be App Defense doing it on its own, whether it's shutting down or isolating that actual virtual machine until it's actually or even quarantining it to say with a vMotion. So App Defense can take specific actions. We have direct integration with Carbon Black. Carbon Black is an eco partner, so if you wanted to utilize Carbon Black integration with App Defense, they do function together and work together along with other tools like QRadar and so on. You can also use other tools like VRA or any other type of cloud management platform that you may be utilizing within your data center. And we talked about securing EHRs. I don't know why the slide's a duplicate. So, utilizing NSX and utilizing App Defense is going to allow us to provide that secure EHR when it comes to microsegmentation and adaptive microsegmentation. And again, when we're talking about secure clinical endpoints with microsegmentation and with utilizing things like App Defense, now when patients and doctors and so on are trying to connect into these applications, we're now implementing security controls where from a endpoint perspective, we're providing that security and ensuring that no malicious activity is occurring or data is being stolen from within our data center. So one of the things that you may ask is, we got these tools, but how do I take it and put it in my environment without breaking anything? And how do I implement this? So you need to understand your environment. So we have applications across virtual, physical, and cloud, obviously. And we have different application models. So whether it's network flows, ingest processes, user groups, using CMDBs like ServiceNow, and then other things like blueprints and manifests. Being able to have that visibility and into both our virtual and physical and cloud networks, it can be a challenge. It can require many tools to be deployed within the infrastructure, and different entities managing these tools. Well, with vRealize Network Insight or Network Insight as a service, we offer it in 2 different form factors. One is an on-prem based deployment, which is our vRealize Network Insight, which is virtual machine-based deployment on-prem, or we offer it as a service where you're actually, accessing the analytics in the cloud, but and that we're actually gathering from the data center, which could be offered as a service. So providing key components from Network Insights, planning for microsegmentation, optimizing the network. So because Network Insights has a capability of seeing the full 360-degree visibility and analytics of both the virtual and physical network, both including security, it becomes a key tool for all three teams, whether it's virtual infrastructure, security, or networking, to be able to not only see what's going on in the network, but also be able to troubleshoot and plan for changes and monitor from a day two ops perspective, and also ensure best practices such as health and availability. If you do deploy NSX in your environment, you realize Network Insight is our day two operations tool and management tool from a monitoring perspective for NSX. So we have the ability to monitor NSXV, NSXT from Network Insights and provide that day two troubleshooting and visibility. With Network Insights, the first thing that we're going to do is we're going to be able to show you what your east-west traffic flow analysis looks like. We're going to be able to show you things like how much traffic is east-west, how much traffic is switched at layer 2, how much traffic is routed in your data center, how much of that is within the same physical host, how much of that is VM to VM communication within the same host, how much of that is actually going out to the internet. And then we're going to be able to start analyzing the applications inside your data center to start to understand how they're communicating. So we're going to identify workloads with common network behavior. So your applications and your application tiers. So whether it be web, app, DB, depending on how you structure your data center, we're going to be able to start grouping those workloads and those applications, and we'll be able to have full visibility into how these VMs that make up these applications communicate, whether it is from, like, again, VM to VM, VM to internet, VM to other shared physical network resources in the data center, bare metal applications running in the data center, and so on. And we're going to be able to, based off of that data that we collect, build out recommended firewall rules that you could push out to NSX and implement at the distributed firewall level. Which is simplifying, implementing microsegmentation and getting down to that zero trust model that we're going for. A couple other key things within Network Insights is you have the ability to be able to see application dependency mapping. So you actually can see, when we look at various components, I can see a virtual machine. Each one of these rectangles here represents a physical host. I can see the communication flows from this virtual machine, which is my DB admin VM1, as it utilizes VLAN 629, communicates out to a physical switch, a physical Palo Alto firewall in this case, another physical switch, and then comes in and starts actually communicating within the host that are running NSX. So, this shows us both non-NSX and NSX environments. NSX is not a requirement to utilize this tool, but we can actually see as we traverse both the physical VLANs and VXLANs, which is the extension that NSX utilizes. And then we can also see things like the third-party firewalls, the distributed firewall, and each one of these elements is dynamic, and that's what these boxes are showing here. So I can see if I was to click on this Palo Alto firewall here that's in the path flow of the physical network, I could actually see all the information on that Palo Alto firewall. I can see the routing table, the MAC table. I can see what type of firewall it is, what version operating system it's running, and I can also see the actual firewall rules that are in place in between these two VMs on that Palo Alto firewall or any other third-party firewall, so I can understand what rules may be allowing or blocking traffic in this path. Network Insight also uses a simple contextual search. So just like Google, you can go in and you can type in things like, for instance, show path from lab DB1 to the internet. And you're going to get a diagram just like we see here on the screen, where I can actually see my virtual machine and the path that it actually takes out of the virtual environment to the actual physical environment and communicates out to the internet. And then we're going to provide, again, as I mentioned, the operational microsegmentation operation microsegmentation, day 2 readiness for monitoring and troubleshooting. So we're going to look at the intent versus the realize. We're going to look at the overlay and underlay troubleshooting. We're going to monitor and provide all the change and audit and compliance from a security perspective. We're going to look at analytics, such as like elephant flows and so on, top talkers. And then we're also going to, we also have a PCI dashboard integrated and are implementing other dashboards where we can actually analyze the virtual machines and applications running within the data center that are within scope, for instance, let's say with PCI, and we can provide a detailed report to an auditor as to whether they're in compliance or out of compliance. And we can also provide alerting to you and you know, make it aware whether you have an application or a virtual machine that has fallen out of compliance with PCI DSS in a virtual context, and so that way you can make those modifications and changes. And all modifications and changes within Network Insights are logged and can be accessed for well over a year as we function as a time machine. If you're interested in seeing what your data center looks like from an east-west traffic perspective and seeing, you know, what, you know, how, you know, what the flows look like and so on, what you know, the things I've covered with Network Insights, we do have a free network assessment. So basically we will come out and we will provide you with access. You get 60-day access to the product, full access where it's just deployment of 2 virtual machines. It'll start collecting the data from the virtual and physical infrastructure if you choose to add the physical infrastructure. And we'll provide you with detailed reporting as to what traffic looks like from an assessment, whether it's security assessment, microsegmentation, top talkers, all that different features that we include in the product. You'll get full access to that and be able to see what your network looks like and both virtually and physically, and what the communication patterns are between your applications. And that is something you can ask your account executive about if you're interested in it for the Network Insight network assessment, and we can go ahead and get that set up. It's a pretty easy process. It takes about 3 hours to get it installed, and then we usually give you, you know, we'll come back after, you know, 3 to 4 days of analyzing data and go over it with you and go through different components within the tool and show you various features. I talked about our eco partner system that we have. Here's a list of, you know, just some of them. The list grows every single day. You'll see, you know, from an orchestration and management, we pretty much work with just about everybody out there. Networking and security service integration. You know, I talked about Palo Alto, Checkpoint, Fortinet, Cisco, Symantec, Juniper, you know, F5, McAfee. Of course, from a networking infrastructure, we're vendor agnostic, so we don't care, you know, what the underlay network looks like. It could be Arista, Cisco, Dell EMC, Juniper, whoever you may be utilizing. And then same thing from a compute infrastructure. We have the ability to function across various platforms and operation and visibility tools also that integrate with NSX and App Defense. And this is just a few different, you know, customers out there that within the different, you know, that we're delivering services. So not only in healthcare, but in service provider, finance, technology, and so on. So if you're interested in learning more about NSX and learning more about App Defense and so on, you can go to vmware.com/NSX. You can go to, if you want to take a free hands-on lab and actually toy around and get a hands-on feel for NSX, Network Insights, App Defense. All of those tools are all of the products are available. You can access hands-on labs free 24 hours a day, 7 days a week, and go through different scenarios and deployments. We also have integration with third-party partners in those hands-on labs, so you can actually see how those flows functions. And then we also have connectivity to various communities based on the various products that we discussed today. And with that, that is our presentation for today. If you have any questions, feel free to go ahead and ask those in the Q&A window, and we'd be glad to answer those for you. If there aren't any questions, hope you have a great day.
Yeah, Matt, thanks for the detailed presentation. I don't have any questions in the Q&A, so we have few minutes left. If you wanna quickly review the VMworld announcements, or we also doing a follow-up with different customers to review those in detail, so I can do that. And I think you mentioned some of those during the presentation too. So if you don't have anything else, and if there are no questions, I think I can stop the recording and wrap it up.
Yep, sounds good.
Cool. Any questions? Going once, going twice, going last time? Cool. Thanks, everyone. We had a good audience today, and I will post this recording online on LinkedIn and YouTube, and I will forward you the link. So in case anybody missed it, who might be able to take advantage, you can share with them. Thanks a lot. Have a good day.
Thank you.